All right, so all of a sudden everyone's worried about token costs and how expensive AI is now, especially with Fable.
That's $100,000 a year per agent. We're getting to a place where we have to be
on a single task. So clearly, like, you can't lump that all into a $20 per user per month fee. So that's really
The open source models are about 3 to 6 months behind the frontier models, right? But they're 99% cheaper for inference.
So that is what is causing this issue where we are on an unsustainable path right now.
We're not seeing the type of ROI we'd anticipated.
Yeah, well, I mean, what
They see all the hard problems these models can solve, but yet the expense is still a factor. Now, one solution a lot of people have hit upon is model routing, where they're saying, okay, use expensive models like Fable, really top of the line, very expensive. Use those models for planning and strategy. Let them draft out a detailed granular plan and then hand over the steps for implementation and coding up or whatever it is. Hand those granular steps down to cheaper models like Opus or even Sonnet. And that's fine, but I want to offer a different solution to this AI cost token maxing problem. And I've talked about this a little bit in the past on this channel. I think the solution is not so much model routing, but to build specialized harnesses. What is a specialized harness? A specialized harness is, you can think of it as a less general version of Claude Code or Codex. So Claude Code and Codex are very powerful general purpose harnesses, which will do reasoning and planning at runtime, and they will take any problem you handle, not just coding, any general purpose problem. And at runtime, when you give them your problem, they will come up with some plan based on some reasoning, and then they will go through and execute the steps of that plan. So that's a fully general purpose dynamic harness. But what I found talking to tons of companies is that they don't really need that, and they don't even want that. I think the dark matter, the dark iceberg of enterprise work is repetitively handling large volumes of tasks that need a sprinkling of reasoning and planning and LLM calls in there. And that's what specialized harnesses really give you. So specialized harness is a harness that uses LLM calls, but overall executes a much more bounded, much more specialized set of tasks. So one example I worked on a few months ago was Proceda, which was a specialized harness executing SOPs, standard operating procedures. And the big value prop of specialized harnesses is that it is a win-win situation, both with respect to performance and cost. Because the harness is specialized to your task, you get really great accuracy and performance on that task. And again, because it's specialized to your task, you're not asking the model to solve general purpose problems every time. You can actually use cheaper, lighter models. So not only is it cheaper, you also get great performance. So it's a win on both of those axes. So Proceda was a specialized harness for agentifying or executing SOPs. And then again, I've made videos and written about this. I'll leave links to all that below. And then I tried to climb up the ladder of abstraction in that, okay, how would one take in the specification of a task and then generate a harness for that task or that family of tasks? And that's what I called a harness compiler, a specialized harness compiler. And it is a compiler in the sense that at quote unquote compile time, you can use a very expensive, heavy model to take in your task description, take in your input output examples, and do a lot of planning, reasoning, coding, but finally output a frozen harness. But then that frozen harness will solve instances of your specialized problems with very cheap models. So just like a compiler, you can spend a lot of compute at compile time to optimize your program, but the resulting executable, the binary, is executed many, many, many times. So you just pay one heavy compute cost once at compile time. And it's the same idea. So you spend a lot of compute at compile time to take in a task description and come up with this specialized frozen compiler, frozen harness. And that harness can be used many times to solve your problems. So I think that is a much more apt way to address this AI cost problem. It also aligns much more with the way enterprises think with what they want. And it forces you to think in this task description first manner. And so, with that in mind, I'm open sourcing this project that I've been working on for the past couple of months. I call it HarnessC, Harness Compiler. And it's a GitHub repo. It has an Apache license. I've been trying it on various enterprisey problems over the past few months, and I've gotten pretty good results in that the resulting harness gives really high performance on these test problems I've tried it with. So try it out. I would love to get your feedback. I would love to hear from people who've been tackling similar problems, and if this idea of having a harness compiler resonates with them. I'll leave links to the repo below and also some of my previous articles and videos on this topic. All right, thanks.